Okay, now we're going to go over the easier part, and this is going to be going from the name to drawing the structure. And this is going to be a little bit easy because you have a choice of how you draw it, but it's probably going to be the easiest way you draw it. There's going to be a simple way and a more difficult way. And so we're just going to go over this. So we're going to go over this, and we're going to be looking at 2233 tetramethylpentane. Well, if you remember, pentane is the parent. So I need to draw how many carbons? I need to draw 1, 2, 3, 4, 5. And for this case, it's just best to draw them in a linear method like this, rather than trying to make it bent. Even though it's still, when it's bent, it's still a continuous carbons. So now we have tetramethyl, meaning that we have 4 methyl groups. Where are they located? They're located on carbons 2 and carbons 3. Well, you could order them backwards like this, 1, 2, 3, 4, 5, but it's easiest just to order them going forwards and say 1, 2, 3, 4, 5. Where are these methyl groups? So how many carbons are found in the methyl group? Methyl group is based upon methane, so it's going to be 1 carbon. So I have a 1 carbon group being branched off of the second carbon, and here's the other methyl group off the second carbon. And I have 2 more methyl groups coming off carbon number 3. And that's it. It's a little bit easier doing this. So I'd like you to pause and see if you can apply this to this next one right here. Hopefully you paused and you've come back for the solution. Our parent is going to be heptane. Well, pentane is a 5 carbon. Heptane is going to be a 7 carbon structure. So let's go ahead and draw 7 carbons. So we have 1, 2, 3, 4, 5, 6, and 7. Let's go ahead and just number them for simplicity's sake. 1, 2, 3, 4, 5, 6, and 7 for my heptane. So I have 3 ethyl, so that means off of number 3, I have an ethyl group. How many carbons are in an ethyl group? 1, 2. There's my side group. And I have trimethyl at 2, 2, and 4. Methyl means I have 1 carbon going off of each of these groups. So here, my ethyl is going to be a 2 carbon. My methyl is going to be a 1 carbon. So my 2 carbon comes off of number 3, and I'm going to have 1 carbons coming off of 2, 2, and 4. So it's going to be 1 carbon off of 2, another carbon off of 2, and another carbon coming off of 4. And that is it. So it's a little bit easier going from the name to the drawing or the structure than it is from the structure to the name. So the last concept is looking at the polarity of hydrocarbons. So here's an important point. All hydrocarbons have the same partial positive on every side of the molecule. If you remember, we were comparing water and hexane. Hexane is a 6 carbon structure. Okay? And what we have is it is our string of carbons, and they're all surrounded by hydrogen on every side. But for this example, we're just going to be using methane and doing CH4. So CH4 looks like this, and because it's a small molecule, let's go ahead and draw all the hydrogens. Here's what methane looks like. So if you remember, this is a covalent bond. There's 4 covalent bonds, but it's actually going to be a polar covalent bond because the carbon is going to be winning the tug of war between the hydrogens. What's going to happen is that there's going to be a delta positive on either side, north, south, east, and west of this, which means the carbon is going to be pulling in those electrons for itself towards the center like this. It leaves the entire outside positive and the inside negative. However, if you remember, now we're looking, is this molecule going to be polar or is it nonpolar? Do I have a north pole and a south pole? Well, we have a positive, partial positive on every side, and every hydrocarbon would look like this. Even the ones we've just done, they're going to be completely surrounded by hydrogens everywhere. It's going to be delta positive on the top, it's going to be delta positive on the bottom. So it doesn't matter how they're drawn. Hydrocarbons are all going to be delta positive all on the outside because the carbons are going to be on the inside of the molecule. So what does this mean? Polar or nonpolar? This makes all hydrocarbons nonpolar. There is no north and south. If you go this way, they're both the same charge. There's no north pole, there's no south pole. And since hydrocarbons are nonpolar, this makes them hydro what? Well, if you remember water is polar. And if you like water, you're going to be hydrophilic. But this molecule is nonpolar. If you remember, like dissolves like, only polar things dissolve in water. So since hydrocarbons are nonpolar, they don't dissolve in water. Think of gasoline and water. Gasoline and water don't actually mix. They will separate. Think of oil, like the oil that we eat. Oil is not going to mix with water. It separates from water. It does not like water. It fears water, so therefore it's going to be hydrophobic. So all hydrocarbons are going to be hydrophobic, and all hydrocarbons, think of wax. If wax drips in water, it's going to separate. So all of these hydrocarbons, they're going to be nonpolar. They're going to be evenly surrounded by delta positives, and they're all going to be hydrophobic.